Hello guys, welcome. In this lecture we are going to see about cross product. So before we could go into cross product, let's have a small recap of what dot product is, right? So for that, let me draw three cases of vector representation to explain this dot product. So this is basically, give me a second. So this is case 1. So I have two vectors perpendicular to each other. So this is A vector. So this is B vector. So what it has to talk about the angles between them? Because it's perpendicular, we know it's 90 degree. So what's going to be the formula? The formula is magnitude of A vector, magnitude of B vector, and again you have cos theta. So in case 1, it's cos, the theta value is 90, which is resulting in 0, right? So this means they are not similar. They are what? They are not similar, right? So let's take another case, which is case 2. I have A vector like this, and my B vector this time is going to be somewhere near to this A vector. So this is B vector. Okay, so the angle between them is very less. So in this case, it's going to be, the vectors are what? Are almost similar. Well, I'll tell you why we have this cos theta, why we have taken up this cos theta, why not sin theta. So all these details I'll be telling you. Before that, let's finish off this case 3. Here guys, I have again B vector something like this stretched off, and A vector is here. So as you can see from the picture, these both vectors are what? Not much aligned, not off in the same direction, or the angle between them is larger, right? So what it has the inference? These vectors are, so what it infers? These vectors are almost opposite, or in other words you can say dissimilar, right guys? Now I have few points to talk about this dot vectors. So dot vectors are, like you can say, talks about similarity between the vectors, talks about the directions of the vectors in case of projection. See, I have, let's say I have A vector, and to differentiate I'll pick another color. This is to be B vector. So how much of this A vector lies in the direction of B vector? So these are talking about the projections. Well, now these multiplied values will result in a scalar value. Will result in what? Scalar value for what? For dot products. Having said that, let's get into cross product. Okay, as we have summarized here, dot products talks about the similarity and direction, and see here we have used cos theta. So cos theta basically talks about the how much the angles are aligned together, right? Now for cross product, what I'm doing is, the formula for cross product, before I could even draw the diagram, I'll write here the formula so that you have a picture of it, of understanding before you could see the images. So this is The formula is A vector magnitude of A vector multiplied by magnitude of B vector, and here you are picking what? Sin theta. So when this talks about similarity, cos theta talks about similarity, sin theta talks about the spread or the separation between the vectors, right? Okay, fine. Having said this, I have one more point to add to talk about the values resulting from this. This is going to be what? A vector again, vector value. But in case of dot matrix, what it was? It was a scalar value. But here it is resulting into a new vector. Okay. Now let's understand through a diagram. I have two vectors. See guys, here I am not interested in finding the similarities, or nor I am not much keen about the projections and all, but I am interested in calculating the area lying between these two vectors. Okay, so this is going to be my case 1. I have again case 2 and case 3 which we will be talking about. Let's talk about the case 1. See, the degree between them is what? Because they are perpendicular to each other, it's obviously 90 degree. So when substituting in this formula, the sin theta here, when it is 90, which will result in 1. So anything multiplied by this 1 will give you the product of these magnitude, which means the area is maximum, or in case 1 the area is what? Maximum, because it is in L shape, right? Area is what? Maximum, right? Now in case of case 2, let's say I have two vectors. No, let me erase this one. Okay guys, listen. Case here theta is equal to what? 90 degree. For me, in the case 2, let me take theta to be 0 or 180. So sin 0 will be 0 and sin 180 is again 0. So for differentiation purpose, I am using a different color. See, this A vector and B vector will give you what? Will overlap. Since because the angle between them is 0, so it will be what? Overlapping. There is no area to be calculated, or it will be, you can say it will be like a line, right? So there is no area, no what? Area to be covered or calculated, right guys? Okay, fine. Now what if there is a case when theta is somewhere greater than 0, maybe greater than 0 to 180 degree? So the angle can vary accordingly. It can be lesser or lower based on this theta values. Between these ranges it can vary. So something like this, right? So this can be A vector and B vector. But guys, here you cannot give, this is a partial coverage of area. It's not a full coverage of area, as you can see it here. This is a partial coverage of area between the vectors, right? It is not what? Full coverage. Instead it is a partial coverage, right? Let me write it here. It's a partial coverage. Now we saw that the resulting value is nothing but again a new vector. So how this new vector is going to be is, it will be perpendicular. So it's imagine this is represented in a 3D plane. I'm sorry, the images cannot be clear here, but I'll add up a new image, like a new video for you to visualize it. You can see it in the video after this. See, this vector will be perpendicular to both A vector and B vector, right? So you have different use cases on this dot product and cross product. Let's see where we are using it. In case of dot product, first of all, see, you must have heard about this cosine similarity. Can anyone say what is cosine similarity in the comment section? Okay. So this cosine similarity is used in NLP or recommendation system or word to vec, wherein we find the similarity between the users, the words, how close they are. Suppose for example, good and excellent, they are almost similar kind of words. So good and bad, they are opposite in meaning, right? Like these. And also this dot products computes the prediction as dot products of weight and features, right? And also this dot product is used in every neuron to calculate the weighted input. Okay, like when you multiply the weight into the input multiplied by the weight, right? So when it goes to the activation, it's basically the dot product plus the bias. So it is used in every neuron of the neural network, right guys? Now for the cross product, where it is used, what is the use case? Mostly to find the surface normals or depth direction in computer vision mostly, and to calculate some orientations, like I can write it here for you. In 3D computer vision, generally if you speak about 3D computer vision and pose estimations, like orientations of the joints in humanoid robots or something like that. So for the pose estimations, and used in calculations for the shape of the features. So basically it's used in computer vision, wherein you have angles related to that, right? And the rotation related to it, right? Okay, so that's it guys for this video. I hope I have made some clarity about this dot product versus this cross product. And this is Lakshmi from dSciVerse Infinity Academy. Thank you.